Question 1. We need to determine the overall order as well as the order with respect to each reactant. So let's start with question 1A. Well, naturally, if you have a reaction where you have A plus little b, capital B, going to C, capital C, plus D, capital D, and the order of, and then you write the rate of reaction. The rate of reaction is going to be K times the concentration of A, say to the power of N, times the concentration of B per M. Now, so this reaction is for A, it is with respect to N. This is the order of reaction here. N and M are the order of reaction for A and M. But the overall order of reaction, is going to be N plus M. This is N order with respect to A, and this is M order with respect to B. And the overall order of reaction is N plus M. And so that's what they're asking us here. With A, we've got R equals K. Actually, that will be K times the concentration of A to the power of 0. Because we know that anything to the power of 0, so if we have A to the power of 0, and that is 1. And that's why R equals K times 1. So there is 0 here. So therefore, the order of reaction here is 0. So this is 0 order of reaction. It is 0 because the concentration is to the power 0, and anything to the power 0 is 1. Anything to the power of 0 equals 1. So for 1B, we need to write down we need to determine the overall order as well as the order with respect to each reactant. So these are the reactants for B, X and Y. So we have the rate equals K times the concentration of X to the power 1. Because there's no value there, that means X to the power 1. And times the concentration of Y to the power 1. Now the overall order is going to be, in this case, N plus M, because N is 1, right? And M is 1. So overall order is equal to 1 plus 1, and that equals 2. So this is called second order. That's second order overall. And then we have first order with respect to X and Y. So this is first order with respect to X, which is order 1, first, and Y, which is first as well. And for the C, we know that R equals, well, this time K times the concentration of X to the power 1, concentration of Y to the power 2, and concentration of Z to the power 1. As you can see, we go 2, 1, 1, 2, 1. So the overall order is 1 plus 2 plus 1. And that we can say equals 4. So this is fourth order. So we can say that's fourth order overall. Then we can describe with respect to x, y, and z, which we can write here as first order with respect to, as first order with respect to, there's two of them, x and z. X and z. But also we have second order with respect to y. Now, question number 2. A. We need to determine the unit of k in each of the rate equation in question 1. Well, rate itself, which is r, that equals change in concentration over change in time, or difference in concentration over difference in time. As you can see, the unit for concentration is mole per decimeter cube, and over time, and that can be written as mole per decimeter cube per second. So that's the unit for rate. But the rate is equal to k. So rate equals k, which means they have the same unit, and the unit will be mole per decimeter cube per second. So that's for A. And B, we have the rate equals k times the concentration of x times the concentration of y. I need to make k the subject. Don't forget this is over 1. That's over 1. And really, you can just divide both sides by the concentration of x and y. And then k will be on its own. Or you can just move that down. And move that down. Because this is a product. There's no plus or minuses. So k will be on its own. And that implies that r over concentration of x and concentration of y will be equal to k. So what we can say is we know what the rate for r is. So we know that k now equals concentration of r, because that's what r has its own concentration, which is per mole per seconds as well. So per seconds, because that's what r is, mole concentration per second. So that's what r is, over the concentration of x and concentration of y. So well, concentration have the same unit, so that cancels that. And I've got per seconds over concentration of y. And we can now say that would be, well, we know what concentration is. 1 over that would be mole per to power minus 1. And this one is to power minus 3 here. It will become decimeter cube, because it's 1 over, this is 1 over decimeter to power minus 3. And per seconds, because it's already there, per seconds. So the unit for k in this situation, k unit will be equal to mole to power minus 1 decimeter cube seconds to power minus 1. Well, C, the rate in this case is K times the concentration of X times the concentration of Y squared times the concentration of Z. Again, we need to rearrange that. As you can see, we want to make K the subject. That's over 1. That's over 1. Well, just bring these three down here. So bring them down together. All three of them goes down there. And that will leave K on its own because there are no plus or minuses here. And there's an equal sign between them. Or divide both sides by, if you divide both sides by a concentration of X, concentration of Y squared, and concentration of Z, then it will be the same thing. So you get K equals to the rate over concentration of X, Y concentration squared, and Z concentration. And that will be equal to, we know rate has its own concentration, and which is per second as well, over the concentration of X, concentration of Y squared, and concentration of Z. Well, that concentration cancels that, and so you got these. So what we have now is going to be per seconds over concentration cube, which means per second over mole per decimeter cube or cube. Well, there's a power of 1 here. There's a power of 1 here. So that'll be 3 times 1 and 3 times 3. So that'll be, we can say, per second over mole cube decimeter to power minus 9. So that's K unit. So unit K unit in this case will not be, well, because that's 1 over mole cube, that'll be mole to power minus 3. And this is 1 over decimeter to power minus 9. That will become decimeter to power 9. And that's there already in the numerator. So that'll just be per seconds, or seconds to power minus 1. So that'll be the unit. Now, if we look at question 3, we've seen this equation here. This is ratio 2 to 1 to 2, which means that the rate that these reactants are being decreased, the carbon monoxide is decreasing twice as much as oxygen. It's being used up twice as much faster than oxygen. So that's what's happening. Or you might say that the oxygen gas concentration decreases at half the rate of CO, carbon monoxide, rate. Right? So that's what's happening. Because you're using it up, so they're decreasing, right? But which one is decreasing faster? I mean, the CO is twice as much is being used for every 2 mole of carbon monoxide for every 1 mole of oxygen. So the oxygen gas concentration decreases at half the rate of the carbon monoxide rate.